Hello everyone, this is a simple algebra problem for the Keynesian model. So the best way to start is to remember the Keynesian model is all about where aggregate demand equals aggregate supply. In the Keynesian model, aggregate supply is approximated as income, so then you can write aggregate demand equals income. Now I'm going to use a symbol Y for income rather than write it all out. And then the next thing to remember is aggregate demand can be broken into its four components, which are C plus I plus G plus net exports. I don't think I've given you that symbol yet. The symbol for net exports is X sub n. So that's kind of the setup for solving a Keynesian problem using algebra. That is C plus I plus G plus Xn equals Y. Now let's begin. So we have two consumption functions. Do you see them here? And the only difference is one is y and one is yd. This little d stands for disposable income. So that's the consumption function that you use when you have taxes. And in this problem we're going to have taxes, so we'll use that function. So it would be, instead of writing c, we'll write what c is equal to, which is AS plus MPC times YD, right? And then I is just some number. You'll notice in my notation over there, I is equal to I0. That's just a notation that says it's some constant, I, or I0. And then G is also some constant. Let's just call it G0. And then net exports. Now net exports, I'm going to write it over here for just a minute. Net exports is equal to exports minus imports. And this is a place where students oftentimes make a careless algebra mistake, because when you write net exports, it would be exports, which is X0 minus, and don't forget these parentheses here, imports, which are M0 plus the marginal propensity to import times YD, since we have taxes. Okay, now I've run out of space here, but that whole mess would then be equal to Y to satisfy my equation up above. So all I've done, it looks complicated, but really all I've done is write out C plus I plus G plus Xn in its little pieces. Now let's try one. Let's try a real one with some real numbers. So let's see. Let's imagine that AS is 500, and let's imagine the marginal propensity to consume is 0.8, and let's just let investment be say 400, and let's let government spending be 200, and let's let exports be 300, and let's let imports be, let's see, how about imports can be 100 plus the marginal propensity import. So that's the fraction of your disposable income you spend on imports. So let's say it's 5%, so that'd be 0.05 times YD. See how I did that? So imports looks just like the consumption function. You have an autonomous part, this 100 right here, plus some fraction of your income you spend on imports, in this case 0.05. It's called the marginal propensity to import, and then times YD. And let's let the tax rate be, I don't know, let's say 20%. So little t is 0.20, 20%. So taxes then would be 0.2 times income, 20% of whatever your income is. Alright, so now you want to try to solve this thing. AS was 500 plus the marginal propensity is 0.8 times YD plus investment was 400 plus government spending was 200 plus exports were 300. Now I got to work down here, minus imports, so imports were 100 plus 0.05 times YD. And that whole mess equals Y. Now let me try to clean that thing up. The first thing I'm going to do is I'm going to add up all my whole numbers. So I have 500 plus 400 plus 200 plus 300 minus 100. So I get 1300. I hope you got that. So that's 1300. That's just adding up all my whole numbers now. Plus 0.8 times YD minus 0.05 times YD equals Y. Okay, so in that step, all I've done is gathered up all my whole numbers, and then I gathered up my two YD terms. Now I'm going to combine those two YD terms, so I'll have 1300 plus 0.75 times YD equals Y. See that? Okay, so now I'm stuck. I have a YD, which stands for disposable income, and I have my regular Y on the right side. So I need to somehow combine those things, and the way I do it is I use this equation that I had for taxes. See this right here? This equation. And this is what I know. My disposable income, YD, is equal to my regular income. Here's a little space up here. I'll write in this little space. So right up here. My disposable income is equal to my gross income, Y, minus taxes. And taxes, if you go down to the bottom equation, taxes are equal to little t times Y. Right? So my disposable income is equal to my gross income minus taxes. And by factoring out that Y there, I can rewrite this as 1 minus little t times Y. Now I combined two steps there. I hope you can see that. But by taking the Y out, I have 1 on the left side and I have little t on the right side. So 1 minus little t times Y. So using that information and going back to my original problem, I now have 1300 plus 0.75. Now instead of writing YD, I'm going to write what YD is, and it's 1 minus little t, and little t in this problem was 0.2, that was given, times Y equals Y. Now I can clean that up. I get 0.6. Now I'm going to subtract 0.6Y from both sides. I get 1300 equals 1Y minus 0.6Y, which is equal to 0.4Y. See that? Now I'm going to divide both sides by 0.4, but I'm going to do it kind of in an odd way. I'm going to add this little step. 1 divided by 0.4 times 1300 equals Y. See how I did that? And now, when I just kind of do that, let me do it on my calculator, 1300 divided by 0.4, I get Y is 3,250. So I'm kind of out of space. I'm going to write it right here. Y is equal to 3,250. Now, it seems like a lot of algebra, but what's really happened there is that we started with the equilibrium condition. Let me see if I can mark it for you. Here it was right here. This is the original Keynesian equilibrium, that aggregate demand must equal aggregate supply. Then all we did was substitute what each of those components were from the given, C plus I plus G plus Xn, and then very carefully, without making a silly algebra mistake, we solve for income. So this number down here is equilibrium income. That's the Keynesian equilibrium, where aggregate demand equals aggregate supply. So from that number you can figure a lot of things. You can figure how much were taxes. Well, taxes are 20% of equilibrium income, right? 0.2 times Y. So taxes would be 6,000. In this problem, taxes are $6,500. All right? Oh, I got a big mistake somewhere. Let's back up. 3,250 times 0.2. Oh yeah, look at this. What a mess. The taxes weren't 6,500. Give me a break. The taxes were 650. Taxes were $650, but of course we still have a budget surplus because government spending was only $200 and we raised $650 in taxes. Okay, so now let's think about the trade balance. Again, the trade balance is simply exports minus imports. So exports were 300 and the imports are 100 plus 0.05 times YD. So let me get that. 3,250 was my gross income minus taxes, which were 650. So YD was 2,600 is what I get. Multiply that by 0.05 and then add in 100. So I got imports. I'm going to use this little space over here. Imports were $230. So let's think about this. Exports were $300 and imports were $230. So we have a trade surplus of $70. Trade surplus of $70. And I think that's all we can do in this problem. We found equilibrium. We found the amount of taxes. We talked about whether the government's budget was balanced or not, and it was in surplus. We talked about the trade balance, and it's also in surplus. The only thing left to do in a problem like this is if I gave you a full employment income. So let's say that you had a full employment income, say of 4,000, kind of out of space, but let's say if you had a full employment income of 4,000, you could use the Keynesian model to try to solve that. In other words, you could answer the question, well, how much extra government spending would they need to bring us up to full employment? And the problem is equilibrium's at 3,250 and we need it to be 4,000. And the way you would solve it is this weird little thing over here. It'll show up in every Keynesian problem. See this weird little fraction that's always in the last step before you solve? That little fraction turns out to be the multiplier. I know it's a little different from the formula that you got in the graphical representation. In that case, the multiplier should have been 5, but in this particular problem, the actual multiplier is 1 divided by 0.4, which is only 2.5. And the reason the multiplier in this more complicated problem is less than what it would be in that simple formula 1 over 1 minus the MPC is because we have taxes, which erodes the multiplier, and we have imports, which erodes the multiplier. So again, the way you would do this is you just find the difference between the income level that you need and what we actually have. So we're short $750, right? So we need $750 in extra income, right? Because we have 3,250 and we need 4,000. And we know that the multiplier is 2.5, so you can divide that number by 2.5. Really crowded now. And that will give you 750 divided by 2.5. I get $300. You would need an extra $300 in income to make it work. So I hope you find that helpful. Let's see. You need an extra $300 to get up to full employment. I feel like I rushed that. Let's repeat it one more time. Equilibrium was 3,250. Full employment was assumed to be 4,000. So we're short $750. The actual multiplier in this problem is that little weird fraction that you get at the end. In this problem it was 1 over 0.4. Use your calculator and you'll figure out that that's equal to 2.5. So you just divide the income that you need, the extra income you need, which is 750, by the actual multiplier, 2.5, and that gives you in this problem 300. Okay, hope you found that helpful. Good luck.